Hey there. This video will be something a little bit different from what I usually do. Instead of a straightforward tutorial, it will be sort of a retelling of the journey from idea to final product. So if you have ever wondered how I, and likely many others who make geometry nodes tutorials, know the things we do, this video will probably give you some insight. So let's go. A while ago I found myself once again binge-watching the coding adventure videos created by Sebastian Lague, and in the video about creating procedural planets, Sebastian L mentioned a way to create a sphere from a cube, by subdividing it and setting the positions of all its vertices at an equal distance from the center. I figured this should be easy to do with geometry nodes, and yeah, it is. Just subdivide the cube with a subdivide mesh node, take the positions of the vertices, run them through a vector math node set to normalize, and use the resulting vector for the position socket of a set position node. It's basically a primitive geometry nodes version of Blender's built-in cast modifier. And it works pretty well even for more complex meshes. So how does it work? Well, the key part of this setup is the normalize function, which takes a vector and sets its length to 1. A vector in 3D is basically a structure that holds 3 values that is meant to represent a direction in 3D space. However, it can also be used to represent a point in 3D space. For example, take this cube. It consists of 8 vertices, and the position of each vertex can be described as a combination of values along the x, y, and z axis. This vertex, for example, has an x position of 1, a y position of 1, and a z position of 1. This vertex on the opposite side has an x position of 1, a y position of 1, and a z position of -1. Now, while all the values of this cube's vertices consists entirely of different combinations of negative and positive ones, the actual distance from the center for each vertex is actually greater than 1, and this distance is the length of the vector. Here I'm using a node setup to display the length, or the distance from the center, of each vertex of a 2x2x2 cube. So what the normalize function does is that it modifies the input vector so that the resulting length of the normalized output vector is equal to 1. If you want a good introduction to vectors in 3D space, you can check out this video. I have linked it in the description. So with my bootleg cast setup, I was thinking about ways to make it more interesting, and while I was looking at the available nodes in 3.0, I noticed that there is a mix RGB node. Now, why is there a node for mixing colors in a node system that has nothing to do with colors? Well, while vectors are usually described as 3 numerical values, it's not the only way to represent them. For example, when working with shaders in Blender, you can use a texture coordinate node to map textures to a mesh in different ways. And by plugging it into the color socket of a principled BSDF, or by using a viewer node, we can visualize what the node is outputting. So what do these gradients mean then? Well, instead of using a combination of 3 values to represent a point in space, it's possible to represent that same point with a specific color instead. For example, this point can be described by a vector with the values -1, -1, -1. But it can also be described with the color black. And the same is true for any point in 3D space. This means that it's possible to use the mix RGB node to mix the values of different vectors. So with this setup, the factor of the mix RGB node determines the influence of each of the different positions, and makes it possible to smoothly transition a mesh to a sphere. I thought it was a neat little trick, so I shared it with my patrons and kind of left it at that. A couple of days later though, Legend_0104 shares a clip of a point cloud morphing from one shape to another in my Discord. And after giving this suggestion for improvements, I realized that it's possible to just move the vertices instead. So I fired up Blender and started experimenting, and after a few questionable results, I came up with this setup. As you can see, it's pretty similar to the cast to sphere setup, but I replaced the normalize node with a transfer attribute node. This node is useful for extracting certain attributes of a geometry that can then be used elsewhere in the node tree. Attributes in this case are things like normals, positions, number of vertices, and so on. Basically, you specify the type of attribute you want to transfer, connect the geometry you want to transfer from, then connect the corresponding node to the attribute socket. So in this case, I'm taking the positions of the cube's vertices and transfer those positions to the mixRGB node. I could plug the attribute right into the set position node, but then I can't create any transitions. And of course, the other value of the mixRGB node is the original positions of the mesh. I'm kind of surprised at how well it works, even if it has some minor quirks here and there. For example, if I subdivide the cube, some vertices of the Suzanne head are closer to the middle vertices of the cube, so those positions get used instead. So results may vary depending on what meshes are used to mix between. One cool thing about the setup, however, is that you don't have to use just one mesh to transfer from. And with the mixRGB nodes, it's possible to create any combination of influences of each mesh. At this point, I wanted to see how the mesh would react to any transformations applied to the mixing mesh. Moving it around creates some weird variations, and messing with the scale can produce some interesting results as well. However, the most interesting results, in my opinion, came from adjusting the rotation of the mixing mesh. So I added a value node with the hashtag FrameDriver and plugged it into the rotation socket to automatically animate the rotation. Watching the eyes move around like that is really mesmerizing to me for some reason. This made me want to create an animation, so I started messing around with materials to see how they would react to the changing geometry. UV coordinates seems to work best, though there were still a large amount of stretching. I didn't really have a solid idea of what I was going for, but in the end I decided to go with a rock texture for the base mesh and a marble texture colored green for the eyes. Of course, no geometry nodes animation is complete without some scatter things, so I applied another geometry nodes modifier for that purpose. This is a pretty basic setup. Basically it's using a noise texture, which outputs values between 0 and 1, then compares the output with some threshold. And wherever the value of the noise texture is greater than a threshold, the distribute node scatters points. Those points are then used to instance a bunch of icospheres. I figured since the mesh is morphing around, it would be fitting to have the scattering be dynamic as well. So I connected the W value of the noise texture to a value node and used the hashtag FrameDriver to continuously change the noise texture. And that's the end of this noding adventure. While not really a tutorial in the regular sense, I hope you learned something new anyway. And if not, I hope the journey was interesting at least. See you next time.